Okay, hi everybody. So today we're going to talk about similarity in triangles, right triangles specifically, and geometric mean is the first kind of new term that we need to talk about. Okay, so first of all, what is the word mean in the first place? Well, not mean girls, but the mean is the average in arithmetic, okay? And so when we're not talking about that, the geometric mean is different. In the geometric mean, we use a proportion, okay? And basically, the geometric mean is when you have the same number in a proportion and it's compared to two other numbers. And so in a case like this, it would be x squared is equal to a times b, or x is the geometric mean between a and b. Okay, so the geometric mean of two positive numbers is the positive square of their product. So x is the geometric mean between the square root of a and b. All right, let's take a look at an example. Okay, so let's say we want to find the geometric mean between 9 and 20. All right, we are on page, let's see, what page is this? 665, and this is example B. Okay, so between 9 and 20, it means we go 9 is to x, as x is to 20. And so we go 180 is equal to x squared, or x is equal to the square root of 180. Okay, the square root of 180, if we simplify, that's actually 6 radical 5. 36 times 5. Okay, so the geometric mean between 9 and 20 is 6 radical 5. If we gave a decimal, that would be, I don't know, 12 point something. All right, let's do another one. Let's go your turn, number 7. It's at the bottom of the page, 5 and 12. And so we go, if you want to set up the proportion, you go like this. We cross multiply, and so x squared is equal to 60, and so x is equal to the square root of 60. What is that? It's not an even number. It's a radical. And basically 60 is the square root of 4 times the square root of 15, or 2 radical 15. Again, if we do a decimal, the square root of 60 is in between what? 6, 7 is 40, 8 is 64, between about 7.5. I don't know. Let's take a look on the calculator. Okay, so if we go here and we want to take the square root, let's switch it up there. Clear. We want the square root of 60. Where is that? 7.745. 7.745 approximately. That's the geometric mean between 5 and 12. Okay, now that we know that, is it interesting? Here's a couple of geometric mean. You should be putting all this into your notes. Geometric mean theorems. Okay. Okay. Well, let's start with a right triangle. That's when these are applied. Okay, so we have a right triangle. If we draw in what is called the altitude is perpendicular to the opposite side. Okay, let's call that H. And it creates two segments. It's called X and Y. H is the geometric mean between the product of x and y. So it'd be like this. H is equal to the square root of xy. Okay? And likewise, if we use the same picture, let's add a length here. A, and then let's call this entire side C. We'll call this side B. We know that A is the geometric mean between x, it's the portion of the hypotenuse closest to A, and the entire hypotenuse. And likewise, B is the geometric mean between the portion of the hypotenuse and the entire hypotenuse. Okay, so there's really 3 geometric mean formulas within a right triangle. Okay, we're not going to worry about the proof. We are going to look at, all right, so how do we use this in a problem? All right, so turn in your book to the next page, which would be page 667. Page 667. And look at your turn, number 10. All right, let me recreate the picture for you. So we've got this. There's our right triangle. Here's the altitude. We'll call this X. This is Z. This is Y. And we got 5 and 7. Okay, well, they want us to find X. All right, from what we just learned in the previous is that this is the geometric mean between the parts of the hypotenuse, the X and the Y. Okay, so X is the geometric mean between 5 and 7, the product of 5 and 7. So that's equal to the square root of 35, which is what? 5 point something, but square root of 35 is fine. Okay, so we know what the Pythagorean theorem is, but let's just make sure we have it in our notes. Okay, so the Pythagorean theorem, this is on page 668. It says, in a right triangle, the square of the sum of the lengths of the legs is equal to the square of the length of hypotenuse. Okay, so let's look at a picture. Okay, this is called a leg, this is called a leg, and this is called a hypotenuse. All right, so now the Pythagorean theorem many times is labeled like that, A, B, and C. And so A squared plus B squared is equal to C squared. All right? So that's the Pythagorean theorem. And they go through a proof. We're not gonna worry about the proof of it, but it's just good for us to know. All right. Let's make sure you get these notes, and let's do start on page 671. And let's start with number 4. And let's go all the way through number 21. Okay? 4 through 21, that would be our homework. We're going to make this due on Monday. All right, hit me up if you have any questions. Take care.